Hello, everybody. Today we are going to be going over the homework solutions for uh, the section 3.5. I have the workbook next to me, and we're going to be going through. So the homework is on page 154, and it is numbers 19, 21, 22, 23, 26, 27, 28, and 30. Grab your workbook so that we can go over the solutions, and let's get started. So we start off with number 19, and the instructions for this problem is just to solve the equation. And it's we have two polynomial equations, or one equation with two polynomials in it, and the polynomials are negative 3x squared minus x squared plus 54x minus 40 is equal to 2x squared plus 6x plus 20. And now, so what we're trying to find is we have two polynomial functions, and we're trying to find the points where they intersect with each other. And we can do that just by subtracting one from the other and then finding the zeros. That's the easiest way to do it. So what we're going to do is we are going to subtract 2x squared and subtract 6x and subtract 20 from both sides. So we have negative 2x minus 2x squared minus 6x minus 20. And then we can rewrite our equation as negative 3x squared negative 3x cubed. I wrote that wrong. Oopsies. Let's go back to black with the pen. 3x cubed plus or minus x squared minus x squared, and then negative minus 2x. So we have negative 3x cubed minus 3x squared plus 48x minus 60 is equal to 0, right? Because we got rid of the equation on the left side, or on the right side. The next thing we can do is we can factor out the negative 3, and we get negative 3 times the quantity x cubed plus x squared minus 16 plus 20 is equal to 0. We can then take this and plug it into our synthetic division. And so the 1, let's put in some. So we have a 1 here, and then a negative 16 and a negative 20. So we can write that as 1, 1, negative 16, 20. All right. So we have to find a few things. We have to find what can possibly synthetically divide this, the rational numbers. And we can do that by saying, all right, we have 20 here, and the things that multiply to 20 are 1 and 20, and 2 and 10, and 4 and 5. And probably what's going to end up happening is we're going to have to do 4 or 5, just because we have a cubic equation and the things will multiply together. So let's think if we plugged in 5 here, we'd have 5, 1, then 5, then 6, then 11, then negative, we'd have 1, then 5, then 6, then 11, then negative 5, then negative 25. So that's not going to work. But what if we plug in negative 5? Well, we'd have 1, then negative 5, then negative 4, then 20, then 4, then negative 20. All right, so that one's going to work. So let's plug in negative 5. So we have 1, negative 5, negative 4, 20, 4, and then negative 20 and 0. And then we have to find the zeros for this new function, which is x squared. This is x squared minus 4x plus 4. What if we try 2? Because 2 times 2 is 4. So we have 1, 2, -2, -4, 0. And this tells us what our last one is. It's just 2 again. So we get 1, 2, 0. All right. So we then have, we can then write down this function because this one is going to be just x minus 2. So we can then write in our function right here, negative 3x cubed minus 3x squared plus 48x minus 60 is equal to negative 3 times x plus 5. So we plug in with the negative 5, and then x minus 2. And since there's 2 of those, we square it. So we see that the zeros of these are negative 5 and 2. So our solution is at negative 5 and 2, negative 3x squared cubed plus x squared plus 54x minus 40 equals 2x squared plus 6x plus 20. All right, and that's our solution. It's those two places. All right. Let's do number 21. This time we're doing, it's the same type of question, except we are just doing it in a, we're doing it with different polynomials. So we have negative, ooh, that was not a good 5, negative 5x to the fourth minus, or plus 4x squared minus 12x equals negative 6x to the fourth plus 3x cubed. All right, and we subtract the right side from both sides. So we would add 6x to the fourth minus 3x cubed. And to both, we do that to both sides, and we get 6x to the fourth minus 3x cubed. And we get x to the fourth minus 3x cubed plus 4x squared minus 12x equals 0. So our first 0 is obvious. That's going to be x, right? So we can take the x out and we get x cubed minus 3x squared plus 4x minus 12 is equal to 0. All right. Now we can take what we have left, the x cubed minus 3x squared plus 4x minus 12, and put that into our synthetic division to factor it. So we write down 1, negative 3, 4, negative 12. And then we have to figure out what we put in here to multiply to 12. Okay. Why don't we try 2? 1, 2, negative 1, right? Then negative 2, then 2, then 4. Okay, that doesn't work. What if we try 3? Let's try 3. Yeah, that looks like it's going to work. So 1 times 3 is 3, minus 3 is 0. Then we have 0. Then we have 4. 4 times 3 is 12. And that's, there we go, 0. And then we're left with x squared plus 4, which if you check b squared minus 4ac, well, a and c are positive and b is 0. So this is going to be a negative number, so we're not going to have real solutions to this. So we can take this and we multiply it by x minus 3, and x, that's equal to 0. So the places where this function right here, negative 6x to the fourth plus 3x squared equals negative 5x to the fourth plus 4x squared minus 12x. The places where they intersect are 3 and 0. So we can write down our solution is 3 and 0, because the rest of them are in the complex plane. It's going to be plus or minus 2i. All right. On to question 22. We're trying to find the solutions of the inequality. So we start off with x cubed minus 9x is greater than 0. Okay. So we do this just by finding the solutions to this function, right? And we find the zeros. So x cubed minus 9x, well, it has the 0x. And then we're left with x squared minus 9, which is going to be x plus 9x minus, or x plus 3x minus 3. So we have x plus 3 times x minus 3 is greater than 0. So we need to find every place where this function is a whole. So we can graph it, right? Our function is going to look like we have the coordinate plane. Might as well do a better job since I'm right here, since I have the grid. Right, okay. We can go back to the pen. So we have a point. A point of our graph is here at the origin, and then 1, 2, 3, 1, 2, 3, and it's positive, right? It's positive and it has an odd degree. It's odd and positive. So we're going to start down here and go up that way. So it looks like this function, just by graphing it, we can tell is greater than 0 in -3, 0, not inclusive, because it equals 0 at 0, and then taken with the points 3 to infinity. Those are the points where this function is greater than 0. All right, now we can do number 23. Number 23, we have 0 is greater than 4x cubed plus 8x squared minus x minus 2. All right. This one's going to be a little bit more complicated because we're going to have our synthetic division. So we start with 4, and then -8, then -1, then -2. Well, 1's definitely not going to work for this, right? Because 4 minus 8 minus 1 minus 2 is not 1, is not 0. So we can try 2. If we have 2, then we have 8. Then from 8, we get 0, then 0, then -1, then -2. That doesn't work because we get -4 right here, not 0. So 1 doesn't work. Let's try 1/2. 1/2. We have 2, and then -6, then 3. Sorry, -3, then -4, then that'd be -2. That one doesn't work either. How about, so we're going to start here with 4. How about we try -1/2? That might work. -1/2. So we get 4. 4 goes to -2. Then -8 plus -2 is -10. Then this goes to 5. 5 minus 1 is 4. And then we multiply that again by a negative end. What do we get? Well, we get -2 again, which is -4. All right. That one didn't work. What about -1? -1 would be 4, -4, -12. That one's not going to work because there's no way that we're going to get that one out of there. Let's try 1/4. You guys want to do 1/4? Because 2 divided by 4 is 1/2. We can do 4 and then 1, then -7, -7/4. That's not a fun one to do, but it's not going to add up the right way. Okay, so we've pretty much exhausted all of our options for doing synthetic division. So why don't we try by plugging in numbers? Okay, and graphing it and seeing if we can find our 0, or at least an estimate of our 0. Okay, so if we're going to graph it, then we need to have inputs and outputs, right? What happens when we put 0 in? Well, we're going to get, if we plug in 0, we're going to get -2. Okay. And then what happens when we plug in 1? Well, we get 4 plus 8 minus 1 minus 2. If we get that, then this is going to be 9, right? So we know there's a 0 between 0 and 1. And then we can plug in -1, and we'll get -4 plus 8 plus 1 minus 2. That is 4 times let's see, 4 minus, it's going to be 4 plus 1 is 5, minus 2 is 3. So there's a 3 there. So we know that there's a 0 between 0 and -1. Okay. And we only have 2 zeros in a cubic function, right? And let me look at this for a second. Did I copy that right? Okay. So there's going to be a 0 here, a 0 around there, and it's going to look like that. Okay, so this is what our function is going to look like. It looks like one of our zeros is a little bit beyond 3, and one of our zeros is in between 2 and 3, or 1 and 0 and 1, 0 and -1. So, and one of our zeros is between 0 and 1. Can we try 3/4? I wonder what plugging 3/4 in would do for us. Or if we're going to have an irrational 0. 4, 8, -1, -2. 4, 3, 11. 33/4. Yeah, that doesn't look like it's going to work at all. Did I plug in 1/4 correctly? 4, 1, 9, 9/4 minus 1 would be 5/4. And then 5/16. Nope, that doesn't work. We tried a half, right? 4, 2, 10, 5, 4, 2. Oh, that works. 0. All right, so one of our zeros is 1/2. 1/2. And then we can go on with this one to make it a bit easier for ourselves. We tried a negative 1/2, right? For -2, 8, -4. Sometimes when you plug in zeros, they won't work all that right because you just don't do the math right, and it's easier to do the math some ways with that. And then our final zero would be -2 because 4 times -2 is -8. So we have just a regular 4 right there. 4 and -8, 0. All right, so our function here is going to be 4 times x minus 2 times x minus 1/2. Oh, sorry, x plus 2, x minus 1/2, and then x plus 1/2. And that's our function that gives us the what we're looking at. So we know that if this is 2, this is -1/2, then our function is less than 0 at -infinity to 2, taken with -1/2 to 1/2. All right. So that's numbers 19 through 23. Then we have number 26. Oops. Number 26. The height of a baseball thrown in the air can be modeled by the function h of t is equal to -16t squared plus 32t plus 65, where h of t represents the height in feet of the baseball after t seconds. Explain why the graph of this function shows only 1 0. Well, the question is, why is there only 1 0 on the graph? And the reason is because our function starts at t of 0, right? Our function starts at t of 0 is the start. T equals 0 is the start. That means that at a time before t equals 0, so all of the negative t's, our function didn't necessarily follow that equation, right? Our baseball didn't follow that equation. It could have been carried by somebody out to the field, right? And the height would have been pretty constant for a certain amount of time. And then as the pitcher is winding up the baseball is going to change a little bit. And then as the pitcher throws it, right, it's going to follow that function. But only right here where t equals 0 will the projectile equation begin to do anything. Before that time, it's just going to be about the height of the pitcher's waistline, right? Because he's going to be carrying it. But after that, then there's only 1 0 after that point. It starts above the ground, and we don't care about the function before 0. All right. Now we have number 27. Model with mathematics. The height of a rectangular storage box is less than both its length and width. The function f of x is equal to x cubed plus 2x squared minus 3x represents the volume of the rectangular box, where x represents the width of the box in feet. Find the factored form of f of x. All right, that one's pretty easy. The first thing that we do is we just take out that x, right? Because there's no plus any constant number. So we can take the x out and we get x squared plus 2x minus 3. And we can use the factor theorem to say, well, this is only has multiples 3 and 1. And we know one of them's a negative. So 3 minus 1 equals 2. All right, we're done. X times x plus 3 times x minus 1. Factored. All right, that's part A. Now part B, find the zeros of the function. The zeros are 0, -3, and 1. You know x represents the width of the box. What do the other two factors represent? Well, x represents the width of the box. So the other factor right here, it says the height is less than both the length and the width. So that means that this is the height, right? X minus 1 is height. And x plus 3 is length. All right. And finally, part D. Find the dimensions of the box when the volume is 10 feet. D. All right. Well, we have to find the places where this function equals 10. So there's a few ways we can do this. We can plug in numbers and say 10 is equal to some number times that number plus 3 times that number minus 1. Or we can just rewrite our original equation and set it equal to 0, right? There's a couple ways we can do this. We can try with the numbers. So let's just say 2 plus times 5 times 2 minus 1 is equal to 10, right? 2 minus 1 is 1. So 1. That one works. There should be a couple other possible dimensions, but we don't really need to find those right now because we found dimensions that work. And anything greater than 2 is just going to extend both of these beyond 2. And then this one's only going to get bigger too. So 2 is our largest 0 in this function, the largest thing that equals 10. Anything else is going to be negative, right? Because of the way that the zeros work. So you can just plug in 2, and that's the answer. All right. Then the last two problems that we have to do are 28 and 30. All right, 28. Complete each statement so it means the same as 4 is a 0 of the function. The graph of the function crosses the x-axis at 4. Blank is a factor of the polynomial. X minus 4. X minus 4 is a factor of the polynomial. All right. And finally, for question 30. Veneta, it's a performance task. Veneta opened several deli sandwich franchises in 2000. The profit P in hundreds of dollars of the franchises in T years since the franchises opened can be modeled by the function P of T is equal to T cubed plus T squared minus 6T. Part A, sketch a graph of the function. All right. So we have our function P of T. The profit as a function of time is equal to T cubed plus T squared minus 6T. So let's draw our axes. And they want us to graph it. We know that this function has a 0 at 0, right? So we have T and we have P of T, right? And we have a 0 at 0. And we don't care about any of the zeros before 0, right? So do we have any zeros after that? Well, what's 1 plus 1 minus 6? That's going to be negative 4, right? So 1 is negative 4. And then let's plug in 2. Well, 2 cubed is 8, plus 2 squared is 4, minus 6 times 2 is minus 12. That's a 0. So after 2 years, they become profitable. And then we don't really care about what goes on after that, right? It looks like a T cubed function. But that's our function right there. And we're done with part A. Part B. Based on the model, during what years did Veneta not make a profit? That's easy. You just look. The profit is negative in between 0 and 2. So years 1 and 2. It did not make a profit. The first and second year. Part C, if the model is appropriate, predict the amount of profit Veneta will receive from her franchises in 2020. Well, that means that we have to plug 20 into the equation. And we can do this pretty easily just by putting 20 here and then 1, 1, negative 6, 0, and calculating that. And we get 1, 2021. 21 times 20 is 21 times 20 is equal to 420. 420 minus 6 is 414. And 414 times 20 equals 8,280. Then we add 0 to that. 8,280. So since it's modeled in hundreds of dollars, that means that we're going to make 828,000. So $828,000 in the year 2020. All right. Thank you very much, everybody, for paying attention. I hope that this helped you guys solve the homework questions for this week for homework 3.5. Bye.